Hi everyone, this is the gas walkthrough for May 26th. I'm Philip Newman, and I'm going to be solving Gold Chain Punk by Bill Murphy. This is a Rinban Sudoku. We have normal Sudoku rules, 1 to 9 in each row, column, and 3 by 3 box. Additionally, we have some purple or pink or magenta, whatever you call this color, lines, and the digits on these lines must be a consecutive set of digits without repeats. And they can be in any order. So, for example, this 4-cell line could be something like 3, 5, 4, 6. It can't be 3, 5, 4, 7 because we're skipping the 6. This is no longer a consecutive set, even though these three are consecutive with each other. We can't have repeats even if some of the cells don't see each other. So this couldn't be 8, 9, 8, 7, say. This only has 3 different digits. Those are the rules, and we are going to start with our extreme digits. We have a 1 here. The only way to have a Rinban with a 1 on it is to have the lowest possible digits. So in the case of a 4-cell line, that's going to be 1, 2, 3, 4, and 3 cannot be in these cells. So this is 3, and these are 2 and 4. Now 3 on a 4-cell line needs to have a 4. The range of possible 4-cell lines we can have with 3 on it go from 1, 2, 3, 4 to 3, 4, 5, 6. And 2, 3, 4, 5 in the middle, but all of those contain a 4. We can't put the 4 in this box because we've already got a 4 down here. So this has to be 4. And these 2 digits have to be bigger than 4 because we already have 1, 2, and 4 in the box. So these are 5 and 6. Now we have 7, 8, 9 left up here. 9 can't go with a 5 on a 4-cell line. 5, 6, 7, 8, 9 is 5 digits. So to put a 9 and a 5 together on a 4-cell line, we would have to skip 6, 7, or 8. So these have to be 7 and 8, and actually we have a 7 down here. And then this is 6 to go in between, and this is 9. All right, let's come down here. We have a 9. This is the other extreme. The only way to put 9 on a 4-cell Rinban line is 6, 7, 8, 9. We have a 7, so that 7 goes here. And then this is 6, 8, but now we have an 8 up here. So this is 6 and this is 8. The 7 needs a 6 to go with it on the line. We can do 6, 7, 8, 9, 5, 6, 7, 8, 4, 5, 6, 7. All of those contain 6. The 6 can't go in this box, so it must go here. And these are 4 and 5. And then we have 1, 2, 3 here. The 1 can't go with the 5 for the same reason the 9 couldn't go with the 5. So these are 2 and 3. We have a 3, so 2, 3. The 2 also resolves our 4, 2. And then this is 1 to complete the box, and we need a 4 to complete this line. Okay, next thing, I've actually already solved this. Once this morning, my audio was being terrible again, so hopefully it's better this time, but I do remember the path I took. And the next thing I looked at was these 3 cells. We see 1, 2, 3, 4 in the row, but there's also 5 and 6 in the box. So these have to be 7, 8, and 9. And clean that up a little bit. But to go with them on the line, the only thing we can have is a 6. And then we have 5 and 6 here. There's a 6 in that position. We're going to do something similar down here, but this puzzle isn't quite symmetric. And if you haven't seen it already, I will point out why in just a second. But these 3 digits can only be 1, 2, 3 because we have 6 through 9 in the row, 4 and 5 here. And then these are 4 and 5. Now you'll notice here we had a 6 to resolve the 5, 6. Here we have a 9, so we can't resolve the 4, 5. So this is where the symmetry breaks. Everywhere else, if we look at rotationally symmetric digits, they sum to 10. So 2 plus 8, 1 plus 9, 3 plus 7, 5 plus 5. But 6 and 9 don't. And so we have a little bit of asymmetry, and that means our logic is going to be a little different. In this case, it gave us the 5, 6 here, but it didn't resolve this. All right, in this box, we need 1, 2, and 3. There's a 3 here, so 3 there, 1, 2. These are 1, 2, and 4. We have a 2 and 4 in the column. and so these are 2 and 4. The 1 resolves the 3 there. These are 7, 8, and 9. We have a 7 here. And then these are 8, 9. These are 1, 2, 3, and that one's not a 3. These are 6, 8, and 9, and we have a 6, 8 here, and we have a 6 here. So this is 8, 9, 6 in that order, and that's going to resolve our 7. Oh, that's not right. What did I do? Oh, I put the 6 in the wrong cell. There's a 6 here, so the 6 goes here, and that's an 8, and that's going to resolve our 7, 8, 9 up here. If I don't make dumb mistakes. So now these two cells are from 1, 2, 3, and just like down here, we can't have a 1, so this is 2, 3. We can't have a 1 because there's a 5 on this line. So these are 2, 3. We've got our 1 that gives us 2, 3, 1, and 2 up here. These are from 4, 5, 7, and these are from 4, 5, and 1. All right, over here, we had the 1, 2, 3, so we need a 4 here. That 4 resolves 2 and 4, 1 and 2. Now, these digits are from 7, 8, and 9, but to go with the 5, we need 7 and 8. So the 9 goes here. These are 7 and 8. We have a 7 down here. So 8, 7, 8, 9. These are 1 and 3. These are 5 and 9. All right. So at this point, I found it a little tricky the first time. And so I'm going to show what I found solving it the first time. These are 1, 5, and 9. And then I did some pencil marking in this box. So for example, we need a 3 over here because of the 3. We need an 8 over here. We need a 2 and a 7 over here. And then what I noticed is we have 4 and 6 here. So if you have 4 and 6 here, this cell is not 8 or 7 or 2 or 1, 5, 9 or 4 or 6. This is only a 3. It's a little tricky to see because it only sees the 5 in this triple. We don't have a 5 as a digit for this place. We could also see it as a sort of degenerate X-wing here. 5 has to go in one of these two cells and one of these two cells, so it can never go here. But either way, that's how I saw it. This is a 3, and that 3 is going to give us 2 and 3 here, 1 and 3 here. It means this is a 1, this is a 1. Now we have a 5, 9 pair in the row, so this is 4, 7, 5, 4, 5. The 7 looks over to give us 8 and 7, and now the 7 has to go here, 2 has to go here, 8 has to go here. The 9 here gives us 5 and 9, 6 and 4, 5 and 9, and then to finish off these pairs that we've had since the beginning, 5, 6, and 4, 5. And that is the solution to Gold Chain Punk. Let us know how you found it in the comments, and I will see you next time.